Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 5 of the video on radian measures, and in this video I'm just going to be going through one final example of solving a geometric problem. Okay, so here we have an emblem as shown in figure 1, consists of a triangle ABC joined to a sector CBD of a circle with radius 4 centimetres and centre B. So this is the centre of the circle here. The points A, B and D lie on a straight line with AB equals 5 centimetres and BD equals 4 centimetres. Angle BAC is 0.6 radians and AC is the longest side of the triangle ABC. What we're being asked to do initially is to show that angle ABC, which is this one here, is 1.76 radians, correct to 3 significant figures. So, how am I going to start off finding this angle then? Well, I've got two sides and I've got one angle here. I don't at the moment have enough information to find this angle straight away, but what I can do is I can find this angle here, which I'm going to call x, using the sine rule. So, sine rule to find angles, I'm going to use sine A over A is equal to sine B over B. So sine x, which is this angle here, I'm going to try and find over 5, which is the side that's opposite to the angle, is equal to sine of 0.6 over 4, which is the side opposite that angle. Now at this point I stress your calculator needs to be in radians mode to calculate the value of sine 0.6. So what we have then is that sine x is going to equal 5 sine 0.6 over 4. So I'm just going to get that as a numerical value, which is 0.705, 8, etc. Now, I'm going to have to do sine inverse of that to find the angle x. Which is 0.78355. Okay. And bear in mind, because we're in radians mode, we're expecting values that look like this. This is somewhere in the region of 45 degrees if you were to convert it back into degrees, but we're working in radians, so that's fine. So I'm just going to label on the diagram now that what we found that angle to be is 0.78355 radians, and we're going to use that to find this missing angle here, and we're hoping to show that it's 1.76. So the sum of three angles in a triangle, 180 degrees. But now we're in radians, so the sum of the angles in a triangle is now going to be pi radians rather than 180 degrees. So angle ABC should be equal to pi minus the 0.6 that we already knew, minus the 0.78355 that we've just calculated. So I'm just going to do pi minus my answer, minus 0.6, and it comes up as 1.758, which is 1.76 radians to 3 significant figures. So why the significance of saying that AC is the longest side? AC is the longest side because in a triangle the longest side is opposite the largest angle. So 1.76 is that angle there, and I'm just going to label that onto the diagram as being 1.76. Okay, and then in part B we're being asked to find the area of the emblem. So the area of the emblem, we're going to need to do the area of the triangle plus the area of the sector. Now looking at this triangle and the information that I have, I'm going to have to use half AB sine C with 1.76 as the included angle. So I'll just jot that in there. It's going to be half AB sine C, which is going to be a half multiplied by 5, multiplied by 4, multiplied by sine of 1.76. I'm just going to park that there for a moment because I'm going to add the area of the sector, half r squared theta. Now, the angle that I need for theta is this angle here. So I've got angles that point on a straight line. What do they add up to? 180, but in radians they add up to pi. So this angle here is going to be equal to pi minus 1.76, which is 1.38 to 3 significant figures. So I'm going to use that value in my subsequent calculation. So the radius of the sector is 4, so it's going to be plus half 4 squared multiplied by my angle 1.38. Okay. So just calculating this first bit then, that comes out as 9.8215 plus this here, half times 4 squared times 1.38, which comes out as 11.04. And adding them together, that's going to give me 20.86, which is 20.9 centimetres squared to 3 significant figures. So a few things going on there. If we just review the question, we didn't have the information we needed to be able to find this angle ABC straight away, so we had to find the other one and then use the fact that the sum of angles in a triangle is pi in radians. Similar story here, sum of angles at a point on a straight line is pi radians rather than 180 degrees. And then that's job done. Thanks for your company.